Hello students, our next topic is viscosity. A body moving through a liquid or gas is retarded by viscosity. So what is viscosity? It is a force due to the fluid. It is an opposite force like friction. Viscosity arises because a body moving through a medium exerts forces that set the nearby fluids into motion. This can be explained also by Newton's third law. By Newton's third law, the fluid exerts a reaction force on the body. Okay, the viscous force, which is denoted by Fv, is along the line of motion and also opposes the motion and is proportional to the velocity. Okay, so we can write it approximately as Fv is equal to minus C, a constant, into V. It is proportional to F is proportional to V and it is opposite to the direction of motion. Okay, so C is a constant that depends on the fluid and the geometry of the body. For a sphere of radius r moving at low speeds, we consider in this equation moving in bodies moving in low speeds through a common fluid like water or air. C, the value of C is equal to 6 pi eta r, where eta is called the dynamic viscosity of the fluid. So checking the dimension of eta, where dynamic viscosity, it is ml raised to minus 1 and t raised to minus 1, and the unit will be kilogram per meter second. So the relation F is equal to 6 pi eta rv is called Stokes law. So this is the Stokes law for viscosity. Now at high speeds there will be other forces due to turbulence, and the total frictional force, often called the drag force, can be more complicated and velocity dependent. Okay, for example, sports car designers assume a force proportional to the square of the speed to account for the drag forces. However, in many practical cases at low speeds, viscosity is the only important drag force. Here we include only the low speed viscous force alone. The drag force include only the viscous force in practical cases at low speeds, right? So the only force on a body, if it is a viscous retarding force, the equation of motion will be m dv by dt, which is the acceleration m dv by dt is equal to minus cv. Okay. So once again we have a differential equation. In this case an equation for the variable v. So we have a differential equation and we have to solve this equation to find out the solution for the equation. Because the force is along the line of motion, only the magnitude of V changes. Okay, since V is a vector, it has both magnitude and direction, but the force is along the line of motion, so there is no direction change, only magnitude of V changes, and the vector equation can be reduced into a scalar equation. So we can write it as m dv by dt is equal to minus cv. So this is a simpler form. And now we take C by M. We take a parameter, we introduce a new parameter, tau, that is equal to M by C. Therefore, our equation becomes dV by dt is equal to minus 1 by tau into V. Okay, now we have to, the equation minus dV by tau is the relation to be solved. What is the equation for? The variation, how V varies with time has to be found out, right? Now the equation tells us that the velocity decreases at the rate proportional to its value. So there is a relation. This relation tells us that it is the velocity is decreasing at a rate proportional to its value. Okay. Now we assume a solution. When we take the equation dV by dt is equal to minus V by tau. When we separate the variables, dV by V is equal to minus dt by tau, and we integrate from V0 to V, dV by V, it is equal to minus 0 to t 1 by tau dt. Okay, and on we get the relation ln V by V0 is equal to minus 1 by tau into t. or exponential, taking the exponential, we get V by V0 is equal to e raised to minus t by tau, or V is equal to V0 e raised to minus t by tau. V0 is a constant and e raised to minus t by tau. Tau has also having the dimension of time, so exponential has no dimension of, there is no dimension for the exponential. So our solution for the equation is V is equal to V0 e raised to minus t by tau. Now before leaving this problem, let us look at the solution in a much more detailed way. We introduce the parameter tau is equal to m by c, which has physically the dimension of time. The velocity decreases exponentially in time. So this is the variation of velocity with time. This is the maximum value v0 and decreases with time. Okay, this is the initial slope minus v0 by tau. This is the value at which v0 becomes 0.37 times v0, or it is 1 by e, dog by a factor minus e raised to minus 1. The velocity decreases exponentially in time and tau is the characteristic time for the system. This is called the characteristic time for the system. It is the time for the velocity to drop by a factor of e raised to minus 1. When t is equal to tau, the value of velocity becomes v0 0.37 times v0. So this time is called the characteristic time for the system. Okay.